Hello and welcome back at the FinetLink channel. And after we were done with the dynamic addressing protocol for the IPv4 network, DHCP version 4, today we will learn about the stateless address auto configuration and dynamic host control protocol version 6, which are dynamic address protocols for an IPv6 network. So a little bit of configuring will make your day as a network administrator a lot easier. And here in the video, we will learn how to use stateless address auto configuration to allow hosts to create their own IPv6 global unicast address, and as well as we configure the Cisco iOS router to be a DHCP version 6 server, a DHCP version 6 client, and even a DHCP version 6 Relay agent. And what we will learn in this video will be about explaining how an IPv6 host can query its IPv6 configuration. We will explain the operation of stateless address auto configuration. Even for the DHCP version 6, we will explain these operations too. And then we will do configuring a stateless and a stateful DHCP version 6 server. So before we continue, the first thing that we need to do is about the IPv6 global unicast address. So to use either stateless address auto configuration or DHCP version 6, first thing we have to review global unicast address and the link local address. And in a router, if you need to configure an IPv6 global unicast address manually, so you have to use in the interface the command IPv6 address followed with the IPv6 address / prefix len. And in a Windows host also can be configured with IPv6 global unicast address configuration as it is shown here in this figure. So when automatic IPv6 address is selected, the host will attempt to automatically obtain and configure IPv6 address information on the interface. The host will use one of three methods defined by the Internet Control Message Protocol version 6 router advertisement message received on the interface. An IPv6 router that is on the same link as the host sent out router advertisement messages that suggest to the host how to obtain their IPv6 addressing information. The IPv6 link local address is automatically created by the host when it boots and the Ethernet interface is active. So here in this example, we use the ipconfig command, and the output shows an automatically generated link local address on an interface. We even can notice that the interface does not have an IPv6 global unicast address. The reason is because here in this example, the network segment does not have a router to provide network configuration instructions for the host, or host has not been configured with a static IPv6 address. IPv6 was designed to simplify how a host can query its IPv6 configuration. And by default, an IPv6 enabled router advertises its IPv6 information. This allows hosts to dynamically create or query its IPv6 configuration. The IPv6 global unicast address can be assigned dynamically using stateless and stateful services. Those services are shown here in this figure. All stateless and stateful methods use Internet Control Message Protocol version 6 router advertisement message to suggest to the host how to create or query its IPv6 configuration. Although host operating system will follow the suggestion of the router advertisement message, the actual decision is ultimately up to the host. And the decision of how a client will obtain an IPv6 global unicast address depends on the setting with the router advertisement message. An Internet Control Message Protocol version 6 router advertisement message includes 3 flags to identify the dynamic option available to a host. We have a flag. This is address auto configuration flag. Use stateless address auto configuration to create an IPv6 global unicast address. We have the O flag, and this is other configuration flag. In this case, other information is available from a stateless DHCP version 6 server. And the M flag, this is the managed address configuration flag, which is used as a stateful DHCP version 6 server to obtain an IPv6 global unicast address. Using different configuration of those flags, router advertisement message inform the host about the dynamic options available. And these methods are illustrated here in this example, in this figure, which means that the client needs a router advertisement from the router 1, which means that he needs to get the information about the IPv6 global unicast address. So the options are stateless address configuration only, which is with the A flag as 1, stateless DHCP, which means that stateless auto configuration and DHCP version 6, giving the information about the global unicast address to the client, and in this case the O flag is 1, and the last one is stateless DHCP version 6 only, which means that the M flag is 1. So let's see each of those options, which means that we will start with the stateless address auto configuration. Let's have first an overview about this, and then we will continue. So not every network has or needs access to a DHCP version 6 server, but every device in an IPv6 network needs a global unicast address. The stateless address auto configuration method enables hosts to create their own unique IPv6 global unicast address without the service of a DHCP version 6 server. A stateless address auto configuration is a stateless service. This means that there is no server that maintains network address information to know which IPv6 address are being used and which one are available. The stateless address auto configuration use Internet Control Message Protocol version 6 router advertisement message to provide addressing and other configuration information that would normally be provided by a DHCP server. A host configures its IPv6 address based on the information that is sent by those messages. The router advertisement messages are sent by an IPv6 router every 200 seconds. And a host can also send a router solicitation message requesting that an IPv6 enabled router send the host an router advertisement. So now we need to do the enabling of stateless auto configuration in the router. So how can you do that? For this, we will be referring to this topology to see how stateless address auto configuration is enabled to provide stateless dynamic global unicast allocation. The first thing that we need to do is to verify the IPv6 addresses. So in the router, by using the show IPv6 interface for the giga 0/0/1, we will have the display to the current setting of this interface. And as it is highlighted here, we have the link local IPv6 address, we have the global unicast address and the subnet mask, and we have the IPv6 all nodes group. Although the router interface has an IPv6 configuration, it is not yet enabled to send router advertisement containing address configuration information to host using stateless address auto configuration. To enable the sending of those messages, a router must join the IPv6 all routers group by using the IPv6 unicast routing command in the global configuration as it is shown here in this output. And then we have to verify that the stateless address auto configuration is available because the IPv6 all routers group respond to the IPv6 multicast address as FF022. And you can use the show IPv6 interface command to verify those. So by using the show IPv6 interface for giga 0/0 section join, we can see that now our router is part of all routers group to the IPv6 multicast address as it is shown here. So let's go and see the stateless auto configuration only method. So the first method where the flag A is 1. The stateless address auto configuration only method is enabled by default when we use the IPv6 unicast routing command. All enabled Ethernet interfaces with an IPv6 global unicast address configured will start sending router advertisement message with the flag A set to 1, as it is shown here, and the flag O and M will set to 0. The flag A set as 1 suggests to the client that it creates its own IPv6 global unicast address by using the prefix advertised in the router advertisement. The client can create its own IPv6 address by using its own interface ID, either extended unique identifier method or it have it randomly generated. The 0 and M flag set as 0 instruct the client to use the information in the router advertisement message exclusively. The router includes the prefix length, DNS server, MTU, and default gateway information. There is no further information available for DHCP version 6 server. And here in this example, the PC1, by using the ipconfig command, we can see that is enabled to obtain its IPv6 address information automatically because the setting of A0, AO, and M flags that it's performed by the router 1, which means that you have to perform stateless address auto configuration only and using the information contained in the router advertisement message that is sent by this router. The default gateway address is the source IPv6 address of the router advertisement message, which is the leaked local address of the router 1. As you can see here. The default gateway can only be obtained automatically from the router advertisements message. A DHCP server does not provide this information. So, as the router sends the router advertisement message every 200 seconds, however, it will also send a router advertisement message if it receives a router soliciting message from a host. When a client is configured to obtain its addressing information automatically, it sends a router soliciting message to the IPv6 other routers multicast at the all router groups, which respond to the IPv6 multicast address. And here it is a figure that illustrates how a host initiates the stateless auto configuration address method. You see that the PC1 has just booted and has not yet received the router advertisement message. Therefore, he needs to send an router solicitation message to all the IPv6 router's multicast address at the IPv6 multicast address requesting a router advertisement. And then it will be router 1 as part of IPv6 all routers group, and if you receive this message, it will generate a router advertisement containing the local network prefix, the prefix length, and it will send the router advertisement message to the IPv6 all node multicast addresses. In this case, it will be the PC1 that will use this information to create his IPv6 global unicast address. By using the stateless address auto configuration, a host typically acquires its 64-bit IPv6 subnet information from the router advertisement. However, it must generate the remainder of 64-bit interface ID using one of the methods. And remember, we have the randomly generated, where the 64-bit interface ID is randomly generated by the client operating system. And this is the method now that is used in the Windows 10 hosts. And we have the second one, where the host creates an interface ID by using its 48-bit MAC address. This host inserts the hex value of FFFE in the middle of the address and flips the 7-bit of the interface ID. This changes the value of the second hexadecimal digit of the interface ID. Some operating system default to the randomly generated interface ID instead of this method, due to the privacy concern. This is because the Ethernet MAC address of the host is used to create the interface ID. So, for instance, let's use the IP config output on the Windows 10 PC. Use in the IPv6 subnet information containing the router 1 router advertisement and randomly generated the 64-bit interface ID as it is highlighted here. So it used the first part, the 64 bits from the IPv6 information that is given from the router, and the last part, it will be used by the generated of 64-bit interface ID. But what happens if the process enables the host to create an IPv6 address and there will be no guarantee that the address is unique on the network? Stateless address auto configuration is a stateless process, and therefore a host has the option to verify that the newly created IPv6 address is unique before it can be used. The duplicate address detection process is used by a host to ensure that the IPv6 global unicast address that he is using is unique. The duplicate address detection is implemented by using the Internet Control Message Protocol version 6. To perform this, the host sent an IPv6 version 6 neighbor solicitation message with a specifically constructed multicast address called a soliciting node multicast address. This address duplicates the last 24 bits of IPv6 address of the host. And if the node or device will respond with a message, then the address is virtually generated to be unique and can be used by the host. And if you got a message by a host in the network, then the address is not unique and the operating system has to determine a new interface ID to use. So that is about stateless address auto configuration, and see now the steps about the DHCP version 6. where we will explain the stateful and stateless DHCP version 6. Stateless DHCP version 6 use parts of stateless address auto-configuration to ensure that all the necessary information is supplied to the host. Stateful DHCP version 6 does not require stateless address auto-configuration. Although the DHCP version 6 is similar to a DHCP version 4 for what he provides to the host, the protocols are independent to each other. So there will be 5 steps to obtain an IPv6 address from a DHCP version 7. The host begins with the DHCP version 6 client-server communication after stateless DHCP version 6 or stateful DHCP version 6 is indicated in the router advertisement. And server to client DHCP version 6 message use UDP destination port 546, while client to server DHCP version 6 message use UDP destination port as 547. The steps for obtaining a DHCP version 6 are as it shown here. The first step is host send a router solicitation message, which means that the PC1 will send a router solicitation message to all IPv6 enabled routers. And the step 2 is the router that will respond with a router advertisement message, which means that the router 1 here in the figure will receive the router solicitation message and respond with a router advertisement indicating that the client is to initiate communication with a DHCP version 6 server. And at the step number 3, it's the step where host sends a DHCP version 6 solicitation message, which means that the client now, a DHCP version 6 client, needs to locate a DHCP server and send a DHCP version 6 solicitation message to reserve the IPv6 multicast all DHCP version 6 server address. This multicast address has link local scope, which means that router do not forward the message to other network. And at the step number 4 now is the step where the HTTP version 6 server responds with an advertised message. This is because one or more DHCP version 6 server respond with DHCP version 6 advertised unicast message. The advertised message informs the DHCP version client that the server is enabled for the DHCP version 6 service. And at the step number 5 is the host that will respond to a DHCP version 6 server, because the PC1 now will respond depends on whether it is using stateful or stateless DHCP version 6. If he used stateless DHCP version 6, the client creates an IPv6 address using the prefix in the router advertisement message and a self-generated interface ID. The client then sends the DHCP version 6 information request message to the DHCP version 6 server requested additional information configuration parameter as, for example, DNS server address. If the client is a stateful DHCP version 6 client, the client sends a DHCP version 6 request message to the DHCP version 6 server to obtain all necessary IPv6 configuration information. And then the last step is the step that the DHCP version 6 server sends a reply message, which means that the server sends a DHCP version 6 reply unicast message to the client. The content of the message varies depending if it is replying to a request or information request message. And remember that the client will use the source IPv6 link local address of the router or advertisement as a default gateway address, and a DHCP version 6 server does not provide this information. Let's see the operation of the DHCP version 6 if he is a stateless server. The stateless DHCP server is only providing information that is identical for all devices on the network, such as IPv6 address of a DNS server. This process is known as stateless DHCP version 6 because the server is not maintaining any client state information. For example, the list of available and allocated IPv6 address. The stateless DHCP version 6 server is only providing configuration parameters for a client and not the IPv6 address. And this is illustrated here in this figure. You see that the PC1 receives a stateless DHCP router advertisement message. The router advertisement message contains the network prefix and prefix length. The M flag for the stateful DHCP server is set to the default value 0, which means the A flag is 1, and it tells the client to use the stateless address auto configuration. The O flag 1 informs the client that additional configuration information is available from a stateless DHCP version 6 server. This client sent a DHCP version 6 solistic message looking for a stateless DHCP version 6 server to obtain additional information. For example, as we mentioned before, the DNS server address. So how to enable the stateless DHCP version 6 on an interface of a router? To do that, you can use the IPv6 and the other configuration flag interface configuration command, and this will set the O flag to 1. And as it is highlighted here from the output by using the show IPv6 interface for the interface giga0/0/1, you can see that the router advertisement will tell the receiving host to use stateless auto configure, which means A flag is 1, and contact a DHCP version 6 server to obtain another configuration information, which means that O flag is 1. And in case you need to get an IPv6 address by using a stateful DHCP version 6 server, this option, so the DHCP version 6 stateful is same as DHCP version 4, because in this case, the router advertised message tells the client to obtain all address information from a stateful DHCP version 6 server, except the default gateway, which will be the link local address of the router advertisement. This is known as a stateful DHCP version 6 because the DHCP version 6 server maintains IPv6 state information. And as it is shown in the figure, the PC1 receives a DHCP version 6 router advertisement with the flag O set to 1 and M flag set to 1, which will indicate the PC1 that he will receive all its IPv6 addressing information from a stateful DHCP server. And the PC1 now will send a DHCP version 6 solistic message looking for a stateful DHCP server. The stateful DHCP server is enabled in the router by using the IPv6 and the managed config flag, and this will set the M flag to 1. And the IPv6 and the prefix default no auto negotiation disables stateless address auto configuration by setting the flag A to 0. And the highlighted output in the example here confirms that the router advertisement will tell the host to obtain all IPv6 configuration information from a DHCP version 6 server, which means that the M flag is 1. So after we are done with the information about stateless address auto configuration and the two versions of the DHCP version server as stateful and stateless server. Now let's start and configuring the DHCP version 6 server with all his roles, because the Cisco iOS router are powerful devices, and in smaller network you do not have to separate devices to have a DHCP version 6 server, client, or relay agent. A Cisco iOS router can be configured to provide the DHCP server services. It can be configured to be one of the following, which means it can be a DHCP version 6 server, where the router provides stateless or stateful DHCP version 6 services, a DHCP version 6 client, which means the router interface acquires an IPv6 IP configuration from a DHCP version 6 server, and as a DHCP version 6 relay agent, because the router provides the DHCP version 6 forwarding service when the client and the server are located on different networks. So the first step is to configure a stateless DHCP version 6 server. And to do that, we will refer to this topology to learn how to configure the stateless DHCP version 6 server method. The first step is enabling the IPv6 routing by using the command IPv6 unicast routing, which requires to enable the IPv6 routing on the router. Although it is not necessary for the router to be stateless DHCP server, v6 server, it is required for the router to source IP Internet Control Message Protocol version 6 router advertisement. The step 2 is to define a DHCP version 6 pool name. So you need to create the DHCP version 6 pool by using the command IPv6 DHCP pool followed by the name of the pool. This will enter DHCP pool sub-configuration mode as it is from the third step is configuring the DHCP version 6 pool, which means that router 1 will be configured to provide additional DHCP information, including DNS server and domain name, as it is shown here in the command prompt. And the step number 4 is binding the DHCP version 6 pool to an interface. And since the interface that is connected with the network, it will be giga 0/0/1, you have to go to the interface, and to bind the interface, you have to use the IPv6 DHCP server followed with the name of the pool. And you have to configure even the flag, which means that all flag needs to be manually changed from 0 to 1 using the interface command as IPv6 and the other config flag, because the router message will send on this interface will indicate the additional information is available from a stateless DHCP version 6 server. So the A flag is 1 by default, telling relays to use the stateless address auto configuration to create their own global unicast address. And the last step is to verify if the host will receive IPv6 addressing information. By using the command ipconfig all, we will have all the information as it is highlighted at the output. Confirms that the PC1 has learned the domain name and DNS server information from the stateless DHCP version 6 server. So after we configure the DHCP version 6 server, let's go to configure a stateless DHCP version 6 client. We will use this topology, and a router can remember that can be also configured as DHCP version 6 client and can get an IPv6 configuration from a DHCP server, such as a router function as a DHCP version 6 server. In this case, the router 1 is a stateless DHCP version 6 server. So the steps will be enabling IPv6 routing. The step 2 is configure client router to create and link local address by using, so you go to the router interface giga0/0, which is connected with the server, and you have to use the IPv6 enable. And the step 3 is configure client router to use stateless address auto configuration, which means that by using the IPv6 address auto config, you are configuring the routers to use stateless address auto configuration to create an IPv6 configuration. And the step 4 is to verify client router is assigned a global unicast address. So by using the command show IPv6 interface brief, you see that the Giga Internet 0/0/1 has an IPv6 global unicast address that was assigned to him. And the last step is to verify the client router received all the DHCP version 6 information. So by using the show IPv6 DHCP interface global, Giga 0/0/1 confirm that the DNS and the domain name are learned by the router 3. Now let's configure a stateful DHCP version 6. We will go through this topology, and the steps will be as are following here. So we will enable IPv6 routing. The second step is, again, we will define a DHCP version 6 pool, and then we will configure the DHCP version 6 pool. And since in this case it will be a stateful server, it means that all the information the clients will get from the server, which means that they will get the IPv6 address, DNS server, domain name, and the gateway. After we configure the DHCP pool, now is the fourth step that we will bind the DHCP version 6 pool to an interface. To do that, we have to go to the interface that is connected with our network, and by using the IPv6 DHCP server IPv6 stateful, we are binding our DHCP pool to the interface, and we have to manually to change the state of the flags M and A. By using the IPv6 and the managed config flag, we change the flag from 0 to 1. And by using the IPv6 and the prefix default no auto config, we are changing the A flag from 1 to 0. And with those flag changing states, we are indicating the client to get all the information about the IPv6 to the server. And the last step is to verify host received IPv6 addressing information. By using the ipconfig all, we have all the information here. So depend on the DNS server and the information about the DNS, we have the IPv6 address too. So after we are done configuring a stateful DHCP version 6 server, let's go and configure the DHCP version 6 client. We will use the same topology, but now we are configuring router 3 as a DHCP version 6 client. And we will go through the steps, where the first step is to enabling IPv6 router. Step 2 is configure client to create and link local address by using by going in the interface and using the IPv6 enable. Then we will configure client to use DHCP version server. And this is done by using the IPv6 address DHCP. And the fourth step is to verify client router is assigned a global unicast address. To do this by using the show IPv6 interface address brief, we have the information about the interface that is connected with the server. And the last one is to verify client router receive other DHCP version 6 information by using the show IPv6 DHCP interface in giga 0/0/1. We see that is in client mode. It has this address, domain name, and the DNS server. The commands that we use to verify the DHCP servers are the show IPv6 DHCP pool, which this command verifies the name of DHCP version 6 pool and its parameters. The commands also identify the router, the number of active clients. And we have an example here by if we use the configuration of the slides before. And as you can see in this example, IPv6 stateful pool currently has 2 clients, which reflects PC1 and router 3 receiving their IPv6 global unicast address from the server. And when a router is providing stateful DHCP version 6 service, it also maintains a database of assigned IPv6 address. The other command that we use is the show IPv6 DHCP binding. At the output that will display the IPv6 link local address of the client and the global unicast address assigned by the server. Here it is the output display for the stateful binding on the router 1 for the configuration that we did before, and the first client on the output is the PC1 and the second client is the router 3. The information is maintained by a stateful DHCP version 6 server. A stateless DHCP version 6 server would not maintain this information. So after we were done configuring DHCP version 6 server as a version 6 router as a server and as a client, let's configure the DHCP version 6 router as a relay agent. If the DHCP server is located in a different network than the client, the IPv6 router can be configured as a DHCP version 6 relay agent. The configuration of the relay agent is similar to the configuration of an IPv4 router as a DHCP relay agent. So to do that, we will go through this topology where we have the router 3 is configured as a stateful DHCP version 6 server. PC1 is on this network and requires the service of a stateful DHCP version 6 server to query its IPv6 configuration. Router 1 needs to be configured as a relay agent for the router 3. The command syntax to configure a router as a DHCP version 6 relay agent are as below. The first thing is to use the IPv6 DHCP relay destination followed with the IPv6 address. So in this case, for this example, we go to the router 1, we go to the interface giga 0/0/1 to this interface, and then by using the IPv6 DHCP relay destination followed with this IP and the interface that goes to this router. Here will be the IP of the interface giga 0/0/0 for the router 3 that is connected directly with the router 1.
and the giga-internet giga0/0/0 is from which interface the router is available to get this information. And every time when we do our configuration, depending on the devices and what kind of configuration we do, we have to verify this configuration. And in this case, since we did configuration about the DHCP version 6 relay agent, we have to do some verification. The first command that we use to verify the DHCP relay agent is the show IPv6 DHCP interface. By showing this interface, this command, we can see here at the router 1, it says that the Giga Ethernet 0/0/0 is in relay mode, which means that this router is a relay agent. Then we can use even the show IPv6 DHCP binding. With this command, we verify if the host has been assigned an IPv6 configuration. So since we go to the router 3, by using the show IPv6 DHCP binding, we have the information that we need. We can see that the client link local address has been assigned an IPv6 global unicast address, which means that we can assume that this is the PC1. And the last command that we can use is ipconfig all in the computer, in the PC1 of the network that we had in the topology, to confirm that it has been assigned an IPv6 address. And as you can see here in this example, PC1 has indeed received its IPv6 configuration from a DHCP server. So this is all the information about the stateless address and DHCP version 6, where we explain how an IPv6 host can create its IPv6 configuration. We will explain the operation of stateless address auto configuration and the DHCP version 6 stateful and stateless DHCP version 6 server, and then we configured the servers as a stateful, stateless servers, and then we configured a router as a DHCP version 6 server, stateful, stateless. We configured a router as a DHCP version 6 client, stateful and stateless, and then we configured a router even as a relay agent. And by all those informations, we are done with the theoretical part of the stateless address and DHCP version 6 configuration. So see you to the next session, where we will do some practice in the packet tracer about what we learned today. See you to the next session.